Let me go ahead explaining you a new concept. So let us understand some concept. Finding a relation between the two variables will be done by the correlation. Okay, that's a small part. Here, when do we use this regression models? Is my question. What do we mean by correlation? All of you, what do you mean by correlation? Correlation is a concept where we will use in order to identify the magnitude of relationship between two variables. Okay, fine. Okay, it is to understand the magnitude of relationship between the two variables. So what is the variable that we will try to identify in the correlation coefficient, which is represented as R? Right or wrong? That is all fine. Okay, that is what I'm talking about. That's all I'm talking about correlation. Okay, correlation is different. Okay, in the correlation we will have something called efficient. This is fine, which is represented by R. And I'm asking you, what do you mean by a regression model? Okay, what is regression model? Regression model is something to find the prediction and forecasting. That's good. That is fine. When do we need to use the regression model? When can we use the regression model? See, regression model is one of the machine learning models which is used for the predictive analysis to identify the response variable by counting down all the predictors, whatever, considering them into a quantitative variables. That is how that we have converted even the categorical variables in the quantitative, right? Yesterday, guys, all of you. So regression model can be applied to get out with the predictions by evaluating the quantitative variables. Okay. So what about the linear regression model? Within the regression models, what do you mean by the linear regression model? Guys, data modeled by a straight line. No. A linear regression model, actually I need to mention generally a simple linear regression model. A simple linear regression model relies on whenever you are picking a one predictor to identify a one response variable. Okay, then we will try to implement the, even though then you have the where you have the multiple predictors, out of which when you are picking only one to identify your target variable result. Okay, understand? Guys, did you understand this part? No, are you agreeing with me based upon our explanation or the how we went ahead? right? Guys, just give me 2 minutes. I'll be back. Okay. Meanwhile, give me your answers about the multiple linear regression. I will be coming back. 2 minutes. Okay, you mentioned that used to explain the relationship between the two, one continuous variable, and it's not about the one continuous variable. It's about multiple regression is all about multiple independent variables and one dependent variable. Hmm? Right or wrong? Even though if we find out any one categorical, we will convert that into a continuous quantitative model. Okay. So here what we need to understand here, when do we need to use the multiple linear regression? When can we use the multiple linear regression? We will use the multiple linear regression whenever we have the multiple predictors. Okay. Whenever we have the multiple predictors to evaluate a response variable. Understand all of you? Right? This is how that we need to do. What about the polynomial regression then? Hmm? What about the polynomial regression? Polynomial regression is something yesterday that we have seen already. This one even the polynomial regression works with the multiple predictors. Okay, and a single response. See, anything you take up, you will have only one response variable. Okay, anything you take up. So here the polynomial regression is the one which we are trying to handle. And the polynomial regression, we will have the multiple stuff here with us. Okay, and even though we have the multiple predictors within the polynomial regression, when see generally whenever we have the multiple predictors, we will go for the multiple linear regression. But when the model is not directly fit, why? Because we are going to split the data into the training set and the test set. Okay, test set is the future generation of the data, whereas the training present data, existing data is a training data set. When you are working with a one particular machine learning model, when you are working with when you are trying to fit to our training data anytime, okay, you always has to assume how exactly this model works when I'm going to use with the testing data. Am I right, guys? Now currently you are working and you are trying to fit the model for the training data. But how do you know that it will fit for the testing data? Okay. So that's why we will just try to existing data itself, we will try to split it into 80:20 model, and then we will try to capture the training data, and then we will pass it and we will test it using the test data. Whenever the multiple predictor related stuff is not holding the good value of the R square. What do you mean by R square, guys? Hmm? How do you understand a machine learning model? How do you understand a machine learning model is good, is working good for one particular machine learning problem? Hmm? How do you do this? What is, at least tell me what do you mean by R square? See, okay, fine. You were, see, that is good. That is by looking at the visualization you are talking about, Narayana. Okay, generally, I'm talking about in real, in a statistical way of understanding about a model. What is the measure that you will go ahead with? I already explained you guys that RMSE, what do you mean by RMSE? Mean square error, root mean square error. Okay. Or least squares method, ordinary least squares method will provide you the RMSE, which is going to be a square error, mean square error. Okay. And also one more thing is R square. What do you mean by this one? Coefficient of determination. Coefficient of determination is something that we will use in order to understand the magnitude of the machine learning model, how well the machine learning model is built. Right? All of you? All of you understand? Guys, this is what we have seen as R2 score in each and every program of the simple linear regression model and multiple linear regression model and polynomial regression. Are you all with me, or do you have any questions till now so far? If you don't understand anything else, any one particular specific thing, please highlight it. I will explain you. Ramdinesh has said it specifies data how close to the fitted line or the plotted line, right? That is good. But generally, my question, what I have asked is, on which basis that we could decide the model is rightly fit or not. It's not about the visualizations. Of course, that we will go ahead with the visualization. The very first thing is the mathematical or a statistical understanding of a coefficient of determination and the root mean square error, which should be the lesser one. Okay, all of you understand this one. Anusha, Ashok, Kiran, Narayana, Sunil, Suresh, Ramdinesh. Did you understand? If you don't understand, if you ask me, I will re-explain you everything. This is what my stand from my end. Why? Because this is a machine learning. You are all learning everything. Since from the very beginning, statistics we have completed, R, Python programming, everything we have completed just because of this. If we don't understand this one, it's a problem actually. Understand? So guys, we have only two different types of models. One is a regression and classification and the clustering. Okay, and within these we will try to identify different machine learning models. Okay, now we have gone through the simple linear regression and multiple linear regression and polynomial regression. So if you don't have anything with this, then we have to switch to the some other some other concept now. I've seen the confirmation from the Narayana and Ram Dinesh, but I didn't see the confirmation from any of you guys. Suresh, Sunil, Kiran, Anusha. Are you good? Hmm? Okay. So, guys, now there was a problem we could get. There is a problem, something called a collinearity. Co collinearity. What is this problem? Can anyone understand the nomenclature of this particular name? And please let me know collinearity. The problem of collinearity. What do you mean by collinearity, first of all? Co represents multiple things, right or wrong? Linearity. Linearity represents that resembles the relationship, right or wrong? Hmm? So when we say that collinearity, hmm, we will generally have, whenever we are looking after the models, we will have only two things. One is predictors, and another one is response. There will there will be always only one response variable. For example, if we have the predictor x1, x, okay, and we will have the response variable anyhow every time y. Okay, if you have the one more predictor x1, we will have only one response variable. If you have the one more predictor which is x2, we will have only one response variable, x3, so on. Are you okay till here? Do you agree, all of you? So we understood till now so far, when we have the multiple predictors, how we need to approach. See, when it is something like this, let me tell you, when it is something like this, the situation is something like this, which machine learning model that you will go ahead and fit, which machine learning model that you will prefer here to work with? Okay, see, generally, Dinesh, we will try preferring the multiple linear regression anytime. Why? Because we don't know how data is related, right? Okay, and then based upon the result oriented, then we will jump on to the, why? Because if the multiple linear regression is not going to be the best fit, then we will switch to the polynomial regression. We will not directly go to the towards the polynomial regression. Why? Because unless and until if you don't understand, see, it is not, see, even though the multiple linear regression is not doing well, we never go to the polynomial regression. When do we go to the polynomial regression, guys? Can anyone tell me? The first priority is having the multiple predictors. That is fine. Hmm? I will ask you some questions, some uh, silly questions. I have a one predictor and one response variable. Can I go ahead with the multiple linear regression or not? I'm asking you. You can go, no issues. Who will stop you? You can go. Why? Because the formula is something like this: y is equal to beta naught plus beta 1 x1 plus beta 2 x2. When you don't have the beta 2 x2, this will become 0, and you will get the same formula as a simple linear regression, right? No issues. even though you go ahead with polynomial regression, no issues. Why? Because you are not going to make your square. You are not going to have this one. Understand, all of you? All of you got this? In the same way, any questions, Suresh? Did you understand? According to the formula, you can go ahead. No issues. But still, we have some common sense. Okay. What to prefer before we are performing something. Okay. Right or wrong? Hence, we are going to pick out simple linear regression model. So now at this point of stage, predictor represents x, x1, x2, x3, x4. I have 5 different predictors where I need to consider in order to predict the response variable. Okay. So when do I use the polynomial regression? Whenever the plot is showing the dotted lines or the plotted points are looking in a curvy nature, then I would feel that the resultant model should be a polynomial, which should be a curvy stuff. Understand or not, all of you? Unless if it is not curvy, then you will not go where with the polynomial. Understand? So irrespective whether it is a polynomial or a multiple, there is a problem when you have the multiple predictors. See, generally, what do you mean by correlation, guys? Okay, now I'm asking, how do we identify the relationship between the x and y? The magnitude of relation, how do I identify? See, for example, x is something where the climate every day, weather report, and y is student score. This is the data with you. Do you apply the machine learning model? All of you, please do respond. Do you apply the machine learning model for this? No, you don't. Why? Because there is no relation. That comes to our common sense. But when it when we are into the technical part, okay, when you are investigating some medical analysis, how do you understand the values related each other? So hence we will use the correlation coefficient in order to understand the relationship between the two variables. Okay, here the relationship between the two variables should be existing, okay, in order to plan one particular machine learning model to be applied in order to predict. Okay, so whenever, and also you have to think one thing, whenever you are trying to identify the relationship, one should be the predictor and one should be the response generally. But whenever you have the relationship between the predictors also, what happens? See, x is number of hours of study. Okay, x1 daily attendance of each and every session of a one particular student wise. Why? Because y response y is equal to score of a student. Okay, so x1 and x is should be related, may be related. See, number of hours of study is different. X1, what is x1? X1 is attendance. Okay, and next to total number of tuitions he attended. See, tuitions is equal to number of study hours, right? So these should be closely related, right or wrong, guys? So whenever we have the predictors predictors which are closely related with, otherwise we can say which are correlated, they will turn into highly in- influential signatures that creates the multicollinearity. Okay, multicollinearity problem. Understand, guys, all of you, this concept? What do you mean by multicollinearity? Otherwise, collinearity, whatever you call it as. Did you understand collinearity? This is one of the problem. And in order to avoid this problem, in order to come out of this problem, we need to apply the generalization of the data, or we have to apply something called regularization. Okay. In the regularization, guys, we have L1 and L2 models. Okay. Generally, we call them as lasso, regression, and ridge regression, and elastic net regression. All of you understand this one? So these are all the three regression models that we have to understand closely. Okay. There we will finish the concept of the regression models. Why? Because these are all the stuff where we are trying to fix the collinearity problem. Okay. Or where we are trying to apply the generalization or the regularization. Okay. In order to come out up with the best regression model after the tuning of the regression models, or fixing the issues with the regression models. All of you are with me? All of you are with me, guys? Are you all good till now so far? So we will meet again and we will discuss about the generalization and regularization concept little bit more in detail. Okay, and what do we mean by overfitting and what do we mean by underfitting? Okay, underfitting and overfitting concepts, and then we will jump onto this one. Okay, see you all tomorrow again. Bye. Yeah, we'll share you all the programs. It's not just two programs. I will share you a lot of programs actually. Okay, which are in relation with the uh, whatever that we are going to discuss. Okay. Yeah. See you. Bye.